Well, we are to 1.3 in our Larson text. We jumped over 1.2 because your teacher is not a big fan of the unit circle approach. If you would like to go back through and look at 1.2 stuff, you have access to the textbook. You go right ahead. I can open up homework assignments for you as well with no stakes at all. But I'm not a big fan of the unit circle approach. I will most certainly show you the unit circle, but I don't like teaching it from that method. As I said before, I like thinking about that everything's a frickin' triangle. So there's a couple of different ways of looking at it, and many of you have probably heard of SohCahToa. I'd heard about it before I knew what it was. I didn't know what it meant. But let's go. So let's just start off with a triangle. So it matters where the angle lies. Got a triangle where you have the angle. And then we have to just have these three concepts down from the angle. We have to understand that there's a side that's opposite the angle, right? And that makes sense that would be the opposite. So a lot of times we just write OPP, opposite. That's the opposite side to the angle. And then I like to go over, and then the longest side, of course, that's the hypotenuse, right? That's what we call the hypotenuse. And then that third side, the one that's actually touching the angle, but it's not the hypotenuse, we call that one the adjacent side. So I would just keep the opposite hypotenuse, and the adjacent just happens to be the other one. Hypotenuse is always the longest. Always the longest. And the opposite and the adjacent, well, sometimes the opposite is bigger than the adjacent, but it's neither here nor there. All right. Well, if we have that piece down, depending upon where that angle is, where's the opposite and the adjacent? So maybe I just do this real quick and make a right triangle. Kind-ish. And I put the angle up here, and I say, okay, where's the opposite? Well, opposite, it's over here. It's this one. And where's the hypotenuse? Well, it's the one opposite the right triangle, or the little right thingy. And then the adjacent, well, that's got to be the other one. So we got to have that down, and we're not going to be able to do anything. So start baby steps. Get a little victory. Maybe it's just going to be this. So using these three sides, what we find out is we can form these 6 different ratios. It used to be 8 back in the day, because Greece came up with this many centuries ago. Many centuries ago. And you form these 6 different ratios that define 6 trigonometric functions of the acute angle, a small angle. Just for now, we're just talking about less than 90. And we'll have a sine, cosine, or actually that's sine. I'm not reading, I'm just going. We have sine, cosine, and tangent. Those are our 3 big ones. And then we also have what's called our reciprocal functions, cosecant, secant, and cotangent. Okay, we'll get into all that stuff. We'll define it in just a moment. But let's just keep going. And here we are. Here's all of them. This is by definition. So of a triangle, right triangle with some sort of angle coming out with our opposite, our adjacent, and our hypotenuse, we find that if you take sine of whatever angle it might be, you get the opposite over the hypotenuse. For cosine of the angle, the ratio. So the angle is inside cosine, and it can tell you what the ratio might be of the adjacent to the hypotenuse. And then our tangent will be the opposite over the adjacent. And that's why we flip there and we go sine is the opposite over the hypotenuse. So cosine is the adjacent over the hypotenuse. Ka. Tangent is the opposite over the adjacent. Oa. SohCahToa. SohCahToa. And that's how you can kind of keep it straight in your head, because you don't need to keep memorized anything else other than sine and cosine, maybe a little tangent. You get the other ones for free. Now, sine and cosecant go together. Cosecant is just 1 over sine. And don't let that fool you. All that's saying is just take sine stuff and flip it over. Instead of it being the opposite over the hypotenuse, it's the hypotenuse over the opposite. Secant that goes along with cosine, where cosine is the adjacent over the hypotenuse, secant's the hypotenuse over the adjacent. You're going to see that the last 3 are actually the simplest of all to deal with. Okay. And then our tangent we have, and we have cotangent, and they're just reciprocals of each other. Which is the opposites. So the opposite over the adjacent for tangent, and then it's the adjacent over the opposite for cotangent. Okay, getting to it. Let's go through and let's see what's going on. There's a little key for us. So this is all straight out of your textbook. Let's try a problem. Let's try this guy right here. Let's try this one. And we want to go through and we want to find out what's sine of theta? What's cosine of theta? What's tangent of theta? What's cosecant of theta? What's secant of theta? And what's cotangent of theta? The angle always goes in there with the word. And we want to go find these ratios. Okay. One of the problems we have at this moment is we only have the opposite, right? This is going to be our opposite. And we're given our adjacent side. We are not given the hypotenuse. But there's a formula that, oh my gosh, everybody freaking knows this bad boy. You know it. You may not know it. You may not know that you know it, but you know it. Y'all ever heard of a squared plus b squared equals c squared inside of a right triangle? So I like to call the hypotenuse c. So we can go and solve for whatever the hypotenuse is. Because a squared plus b squared is equal to c squared. The adjacent side squared plus the opposite side squared is equal to c squared. Hold on. I heard the c. Oh my gosh. I'm sorry, guys. It's actually going to be the hypotenuse squared. So let's just replace and see if we can't solve. Because the adjacent is 3 and the opposite is 4. So we have 3 squared plus 4 squared is equal to the hypotenuse squared. I'm going to write it as c. Makes it easier. So what's that? 9 plus 16 is equal to c squared. 25 is equal to c squared. Now we need to hit both sides of this with a square root. You're trying to solve for c, not for c squared. And typically we need to think of plus or a minus. But for this, all of our lengths are going to be positive, and the hypotenuse is always positive. So we found out that our c is equal to 5, or our hypotenuse is equal to 5. So we can take this one right here, and we can replace it right up top. There we go. So you got to have your Pythagorean theorem on point. You know what I mean? The Pythagorean theorem, a squared plus b squared equals c squared. It's also your distance formula. You probably didn't see that yet, but we will. Okay, so now let's go to our said triangle here. We got to take all this stuff out. Move it out of the way. We look at our triangle. Like, boom. Sine. Remember, SohCahToa. Opposite over the hypotenuse. We look for the angle. We're like, the opposite is 4. The hypotenuse is 5. So our answer is 4 over 5. Now we go to cosine. Cosine's the adjacent over the hypotenuse. So the adjacent is 3. The hypotenuse is 5. So we get 3 over 5. Next, we go to tangent, and tangent is the opposite over the adjacent, SohCahToa. Where the opposite is 4, the adjacent is 3, so we get 4 over 3. Now there's a beautiful thing. We get the next 3 for free. Sine and cosecant go together. They're reciprocals of each other. So whatever answer you got for sine, 4/5, we're just going to flip it over and say it's 5/4. Because those two go together. Now let's take our cosine value and our secant value, because cosines and secants go together. Now, that can get confusing. S goes with C and C goes with S. It's like something got lost in the translation. It would have been much nicer if sine went with secant and cosine went with cosecant. But that's not how it works. Sine goes with cosecant, cosine goes with secant. It's unfortunate, but that's the way it works. So we're just going to take it and flip it over. 3 over 5 flipped over, 5 over 3. These are what we call the reciprocal functions. Cosecant, secant, and cotangent are reciprocal functions. Lastly, we have tangent and cotangent. They are just reciprocals of each other. So we take our 4/3 and we flip it over, and we get 3/4. There we be. We got our answers. We found all 6 trigonometric functions for our triangle here of a 3, 4, 5 triangle. Yeah, buddy. Let's go. Let's do another. We're on a frickin' roll. So here we got an angle coming out and it looks like, oh, we're missing our adjacent side. We got our opposite, we got our hypotenuse, but we don't have our adjacent side. So before we go find our 6 trigonometric functions, why don't we go through and say a squared plus b squared is equal to c squared. Well, a being the adjacent or the opposite makes no difference. That's arbitrary. The only thing that matters is c is the damn hypotenuse. That's the only one that matters. So we can say a squared plus, and instead of writing in b, let's write in 1, the other leg, the opposite, is equal to our c squared. Well, that's our hypotenuse, or the 4. So we find out that a squared plus, what's 1 squared? 1, 4 squared, 16. Do some fancy algebra, and we get that a squared is equal to 15. Well, let's hit both sides with this thing with a square root, and we say that a is equal to the square root of 15. Don't you dare punch that shit in the calculator. Just leave it. There's just a number. Leave it. I don't want you writing down 3 point something. Just leave it. Why would you take a perfectly good answer and ruin it and destroy it? It's perfect. It's root 15. Leave it alone. Don't punch that shit in the calculator. You put that on a test, I will mark your ass wrong. Give me the exact answer. Go. So now we have it. We just need to go through and go, well, sine, that's the opposite over the hypotenuse, 1 over 4. Cosine, that's the adjacent over the hypotenuse. And now if you covered up the 4s and the sine over the cosine, like if you just looked at this, if you just looked at their numerators, 1 over 15, right? 1 over 15, you just looked at their numerators. Cool. Let's go look at something else. All right, and now let's go get tangent. So tangent of theta, well, that's going to be equal to our OA, opposite over the adjacent. So 1 over root 15. I swear I said that before somewhere. Oh, never mind. And now let's go get the reciprocal function. So reciprocal, 1 over 4 will turn into 4 over 1. Secant of theta goes with cosine, so we have 4 over root 15. Now, personally, I don't give a shit if you rationalize your denominators, but your textbook might. Your online homework might care. I don't care. We have calculators now. That's a holdover from like slide rules and shit. So, if you just do this, root 15 over root 15, you're going to get that this is 4 times root 15 over 15, because root 15 times root 15 better be equal to 15. And 4 times root 15 just equals 4 times root 15. So there's your solution. Just like tangent could have been written as root 15 over 15. Okay, and then finally our tangent of 1 over root 15, cotangent will just be flip it on over. It's root 15 over 1. We don't actually need the 1, so it's just root 15. Cool, look at all the freaking answers. So I don't want to make this one too long, so I will come back with some more examples in just a little bit. But there would be a few of them for us to solve. SohCahToa. That's that big thing that we're going to be messing around with. It's the fundamentals. This is the very basics right here. We have to have this down. I don't think you're going to be able to solve double-angled trig equations that are in the forms of quadratics, having to use the quadratic formula and by using reference angles. I'm trying to scare the shit out of you. And you don't know your opposite over hypotenuse. So let's make sure we get this thing dialed so we can be successful once things get uber challenging. All right, I will see you in the next one.